And we are live. I hope so, as always.
Yep,
Hello
yep.
everyone. Hello Szymon. In our webinar, today's webinar, which is about the C#9, what do we like or maybe what we don't like in C#9? Because it has a lot of features, so we would like have some small discussion about that. The very first thing is, as you see, we are only two of us. Łukasz unfortunately got sick. So he's probably watching us from bed now, drinking something healthy.
Yeah, a proper Polish drink for flu, etc.
Exactly. So say a warm words to Łukasz and say hello from where you are listening us, because we are always interested in that. So today is about C#9, and the next thing is just to be kind enough to introduce ourselves a little. So maybe you can say, Szymon, a few words about you.
Yep. So my name is Szymon Kulec. I use Kulec as my nickname in my online activities that I want to share with you. And yeah, I never allocate before none. At least I try to not to. So yeah.
That's good. That's good. Allocations are bad, as we all know. I'm Konrad Kokosa, and I'm author, speaker, blogger, trainer, however you call it. I'm interested in performance and internals and advanced stuff related to .NET in general. And as I'm saying here, performance is easy. You only need to understand everything, and then you can make things faster. And Łukasz, he unfortunately is not here today, as we said. He is just awesome, but unfortunately sick today. So stay healthy, Łukasz. Okay, so the title is what we don't, or maybe what we do like in C#9, because as we know, C#9 has been announced by the end of the previous year at .NET Conf. We have C#9, so we have 9 versions of C#, and it introduces pretty a lot of features. Like on this page, what's new in C#9, there is 14 features being mentioned by authors of it from Microsoft. So we have a lot of new features being added. It is one of the biggest improvements since years, I believe. I don't know.
I think so, and I like the fact that it's. I mean, in some of its parts, it's built on top of the previously introduced parts of the language or features in the language. So it's not that revolutionary, but it's a really big step in the evolution of the language. At least that's my perception.
Yeah, we see this improvement that they are adding somewhere here and there, and in the next version there is some kind of improvement of it, or making this or that feature more flexible. So it is nice to see all those features, although obviously there is some discussion. Maybe there are too many features being introduced at the same time. Maybe the speed of adding all those features is too big. We can elaborate a little during today's webinar. So we have this list is sorted like copy pasted from this from this page. So this is not in an order that may be any significant for us, but it is somehow at least 2 most important features are at the top of it. So we have records and init only setters. And I believe everyone can say that those are 2 most important ones from everyday regular, let's say, typical .NET developer, whatever typical means. But it is the most high-level feature that has been introduced: records and init only setters. So the overall agenda for today is not to cover all those features, obviously, because it would take like a few hours or few days if you would like to discuss all those features in details. We thought that it may be interesting just to take few of those features and elaborate about them a little. So I've choose some feature, Szymon chooses some feature, Łukasz also choose some feature, but unfortunately he is not today. But every of us for sure agrees that records and init only setters is something that will change everyday typical development, let's say. At least we cannot ignore records. Why is that? Because they are pretty nice features. Like record is something that provides very nice, concise syntax for common use cases. So we for sure like this, and we cannot say we don't like records or init only setters. They provide pretty powerful lowering. Lowering is a concept that the language introduces some high level syntax for something that is then translated into bunch of code, more complex code. So you write a few lines, for example, or a single line, and this is then changed by compiler into few lines, dozen of lines, and this is exactly what is happening with async or with let's say iterators when you yield return something and so on and so on. And records is another example. So you write record type and then it is changed by the compiler, by C# compiler, to something more complex. And then out of a sudden we have a lot of interesting features like automatic fields, properties generations, obviously constructors, all this cumbersome code that you need to write from by hand is now automatically generated, value-based equality, hash code, copy, clone, print members, a lot of things that are automatically generated for you. So it's hard to say it's not useful. For sure there will be scenarios that are useful.
Yeah, I think it's worth to add that if you think that if you have this perception that it's maybe it's not that useful, please recall a situation where you had a class, whatever type you were writing, and you needed to basically override all these methods. So with the get hash code, create the copying constructor or kind of like a copy method, and then of course override equals because it's not done by default. So if you take all these experiences, that's basically records address them pretty nicely.
Exactly. And C# team recognized this commonly enough written that it will be beneficial to introduce this out of the box, so it will be auto-generated for you. Moreover, we have so concise syntax like positional records, so in a single line you can define the type that has all those fields and all those automatically generated properties. The construction of records with expression, pretty a lot of things has been added here. So I can't imagine a .NET developer, C# developer that will be not aware of records after this year simply. Probably we will see more and more usage of it. And typically everywhere where you are creating something that is maybe not so super logically rich and doesn't contain a lot of business logic, but for every type of DTO, view models, everything that is mainly for data and requires all those members, right? So these are the typical use cases for records. Because we had it and we needed to write it by hand, and now we have an automatically generation of it. So you can do a lot of things with them. So I even created this article that is about let me just click it and show you. First of all, you can use records before .NET 5 because what's important, sometimes people are let's say misunderstanding this, that .NET 5 is required to use records. You can use them before. It is the, let's say, C# 9 feature, but not .NET 5 feature. So you can use it before, and then you can make a lot of interesting things that I'm providing in my article. So record is just an out-of-the-box generated class with all those members, but this is still a class. So in more sophisticated scenarios, you can still combine them with generics, and they can implement interfaces, and then can be even partial if you are using them for some auto generation of combined with source generators. They can use attributes. So I believe we will see some interesting use cases of record. This is not only for first name, last name record example that we can see in documentation. I'm pretty interested what we will see and what will be the adoption of records in an everyday programming. So they are pretty powerful, right? And that's super interesting. And I believe we will use them in web APIs. We even think about using them in a test builder pattern, because we have this nice with expression. So we can build an object from another object, adding some new features to it, so, and setting some data, for example. So we will see, simply. I'm pretty interested what the future will bring regarding records. I don't know, Szymon, if you have anything to add regarding records. Maybe you are so.
I mean, I fully agree with you that it provides a lot of capabilities, and that the future is unknown, but in a positive sense, that hopefully we'll see more and more usages that will enable us to write less, but the code hopefully will be fully understandable as well, and we'll just spend less time on typing and providing basically more value in less time.
Exactly. So we really hope it will bring some awesome future for us. Mm-hmm. But not only records are added, and that's mainly we are just saying only those few slides about it, because when we are saying C# documentation, I don't know, articles, everything related to C#9, for sure everyone is describing records. So we decided to omit this part, because this is just so often that maybe we thought maybe it will be nice to throw something else. Obviously we can elaborate, for example, whether records are a good feature for writing the value objects or not. We will leave you with an open question for that. Then we have a lot of other features, and I would name all of them like syntax and type system improvements. So there are pretty minor ones, like now you can discard parameters in lambdas, which is not so super rocket science change. For sure convenient in some scenarios. You can now extend any type with gen enumerator, so any type can be now enumerable simply. So you can make, I don't know, time span enumerable, or even I don't know what the crazy idea can be, but any type now be inside the for each loop. For sure there will be some scenarios for that, right? Target type new expressions, target type conditional expressions, pretty nice features, and they have for sure their use cases, which obviously also we may cover in our course or somewhere, but we choose another set of features that we would like to describe. So Szymon, you have chosen the low-level stuff, right?
Definitely.
We are .NETos, we cannot omit.
We are .NETos, so we can't live without integers, raw data, and stack initialization.
And pointers.
And pointers, of course, of course. I didn't want to mention the forbidden word, but anyway, here we are. So beside the high-level constructs and high-level stuff, C# 9.0 brings a lot of low-level elements related to as we mentioned, native size integers. We can finally obtain function pointers, and also if you ever consider the overhead of the zeroing of the stack, for instance, when you do stack alloc with span, now you can simply say that you are happy with obtaining an initialized memory. Before that, there was no way of saying that or expressing that in C# itself, even though there was an option for basically defining that this specific method doesn't require initialization of its local variables. So now in C#9, you will be able to provide it both for the method itself, but also with some methods from the unsafe class. You will be able to move on and define a variable without its initialization.
Yeah, awesome. And for performance, obviously, reasons mostly.
I'm sorry. It's like obvious thing for me. So probably again, I forgot about mentioning that. But performance and speeding things up. These three things are really important in this area.
What is interesting about this locals init flag is that the JIT is interpreting this so safely that it is even safe enough to make it a default choice for your whole program. So you don't need to think about it per method level, but you can attribute the whole module with this flag, and then every method will use it, and JIT will just interpret it properly. That's a nice feature. That's not the case with function pointers. Sorry, you need to use them and understand them to make use of the performance benefits they give you. So native sized integers. Can you elaborate, Szymon, a little bit about
it? So let me provide some hints for nints and new ints, or however that should be pronounced. And if we could go back just a little and let's start with some assumptions, or I think like a common understanding of how .NET framework works, or .NET 5 nowadays. So the basic thing would be probably, or the best statement about .NET would be that the framework itself tries to do its best to abstract what lies underneath. By what lies underneath, I mean not only the operating system, but also the underlying hardware, so that you are safe to write manage code in an efficient way that is capable of running on any kind of hardware.
Sorry, not that.
No worries.
Yep, we are back.
Yeah, and it's often assumed that, nowadays it's changing a little bit because more and more people are running .NET, for instance, on Raspberry Pis, but still I think that there is this perception that it will be run on x64 architecture, and this has the following implications or following assumptions as well. Some people, or maybe not majority, but there is this assumption that the underlying hardware is little endian. By little endianness means how the integers or how numbers are written in memory. With little endian, it means that lowest bytes are written first, and then with big endian, the highest bytes are written first. So with this in mind, we could think about so if that would be the case, why binary primitives class has so many methods then? By providing both the methods for writing big and little.
And those binary primitives, if you can say a few words about them, what they are for. Okay, we lost Szymon for a moment, so let's wait until he gets covered from the deepness of the internet. Okay, hello, Szymon.
Yeah, sorry for the hiccup. So not everything is little endian. That should be our understanding and the assumption, even though the .NET provided by API provided by .NET tries to abstract it properly. So
could you just say a few words what those binary primitives are for people?
So basically binary primitives, that's a class that provides you with capabilities of writing primitive types like integers, longs, oolongs, and short, for writing them to the span. And it abstracts away all the different cases, like I mentioned, the little endian case. So if you try to write an integer in little endian encoding on little endian machine, it will just work. If it finds a mismatch between the endianness of the underlying hardware and the method that you called, it will do the proper reversal of bytes in this specific number, and then will write it properly. So it's really nicely optimized. And again, it takes into consideration all these abstractions that are put on top of the actual hardware.
Awesome. Okay, so we have this little endian assumption then.
I mean, the second assumption is related to the alignment to the word boundary. For x64 CPU, that's not a big deal, but there are architectures where you can't easily write, for instance, a long or an integer across word boundaries. By word boundary, I mean the boundary provided by the underlying architecture. And you can follow it up with a question. So if that wasn't the case, why would .NET provide unsafe write unaligned? And again, if we took a look at binary primitives at the very last call, or sorry, maybe the very last line of every single method trying to write an integer, short or long to the provided span, the very last call is actually unsafe write unaligned. And again, for architectures like x64 CPU, this is just fine to write as it is. But there are architectures like ARM, which actually need to align it properly. So again, we can assume that it's just fine and we always run on x64 CPU, but still .NET provides all these capabilities that help us to think in this way and to abstract all the underlying hardware differences.
Yeah,
so that
we have more and more those differences. Like obviously x64 is the most popular one, but now we have Apple going to the ARM M1 processors, which will be supported by .NET. And we have also different smaller machines being supported. So this assumption is, as you said, not so common. I mean, common, but not always valid.
Yeah, and again, it's properly abstracted away by the provided APIs from .NET BCL. So that was the second one. And there is the third one as well. So with x64, there is the assumption that, so we have 64-bit machine, so the machine word will be 8 bytes long. But we could ask the question, so what if we run .NET on 4-byte word machine? And again, this is like goes back that the .NET properly abstracts the majority of these cases and covers them with different APIs. But in this case, we need to dive a bit deeper. Yeah, so if we wanted to think about code and structured code that properly deals with these different kinds of architectures, by different kinds of architectures, again, I mean whether the hardware word length is 4 4 bytes or 8 bytes, we could define it in the following way. If we could show the way, we could use the macro and basically write if the target build is 64-bit. We could define the nuint in using the using statement, and then just assign it unsigned integer 64 bits long. For the other case, we could use the 32 bits long integer and just assign it to the very same alias. With this, we could just write the underlying code using the nuint, and that would be compiled properly according to the build and the target CPU architecture. And actually, if you took a look at .NET Core, I think before it was before the repo was named .NET Runtime and before the great merge and the great unification, it was done in this way. So if we could take a look at the huge diff that you can find on GitHub, and if you basically just write an int or new int, you will see that there are massive changes. I think it's like 40 or 50 files that had this kind of statements that basically were differentiating the build according to this target 64-bit flag. And it was using aliasing to provide this nuint before C#9.
A lot of interesting if devs. I always like that.
Yeah, it gives me goosebumps. So let's move on with it.
So just to confirm, I've run the Zoomit application. You see in the, for example, array CS file from this repository that indeed we have all those, scary, they were working, right? But we had those ifs. So indeed, Szymon is right. That code was in the repository before C#9, right?
Yeah, and with C#9, we are covered, and we can use these nint and nuint aliases types provided in C#9. So the first and the most important fact is that they provide native-sized signed and unsigned integer types. By native size, I mean that if you run it on a machine with CPU that has 8 bytes long word, it will be 8 bytes long. If you run it on a machine that has 4 bytes long machine word, it will be 4 bytes.
So it automatically knows, right? It is aliased somehow internally.
Yes.
Awesome. So it seems it should simplify writing, right?
Definitely, and we will see samples, but it basically ensures that you are covered, and this abstraction on top of the native-sized integer types is done for you. I think that I'm not sure if that's a politically correct statement, but I would say that it provides less ways to mess up the code. For instance, dealing with the two-pointer and all these different methods that we will see in a while. It basically helps you to write much cleaner code that still is based on the native-sized integers.
Awesome. Without ifdefs.
Without ifdefs. And if you wanted to think about it as a wrap-up of another type, you could think of it as a struct that basically wraps up the IntPtr, the forbidden fruit of .NET type, which actually defines a native-sized pointer.
That's the very common confuse, as far as I believe, when people are seeing those nints and new ints. What is the relation to the IntPtr? Because it is something else something, another type that is also machine-wide depending on the architecture. Do you will cover the difference?
Yeah. So let's leave it as the cherry on the top, and
so
we will answer this question
answer.
at the very end.
Awesome. So let's move to this example. Yeah.
Yeah. So there are several examples that you can search for, and I strongly encourage you to go to the .NET runtime repo and basically search for nints and new ints to see all the probably removals that were done by introducing this new concept to the code base of the .NET runtime itself. But here I extracted work or changes that are related to span helpers. If you are not familiar with the span helpers, whenever you call a method on a span or an array, it's highly likely that at the very end of the call, it is the span helpers method that is being called. As you can see, there is no span. For instance, in this contains method, there is no span. There is just by ref t served space because span was removed before the call of this method, and it's highly optimized code for instance, searching like contains or finding the index of a specific item. So think about it as a like really low level, really fast helper methods that are used in publicly accessible API. Whenever you call a method on span or an array, it's highly likely that this method will be used. And with this contains method provided by span helpers, you can see that before the changes, it was using IntPtr. I'm not sure if I pronounce it correctly. Fortunately, nints are much easier to pronounce. And it was using IntPtr because to avoid this unnecessary truncation, whenever we would cast long to int and then go back to long again. As you can see below, it does some black magic with pointers because it casts length to a pointer. And then within the for loop, as you can see, there is this two-pointer method. It's a method that will be inlined and it won't have this kind of overhead. But if you take into consideration the mental overhead that you need to pay to understand this method, we have some length being casted to a pointer, and then we have to pointer method being called in the for loop. I mean, even if I do like low level stuff, it's like on the boundary for me, and it's like almost hard to understand and to follow because it requires loading all of these constructs to your head. So that was before nints.
All these tricks probably means some really bad happens. Some really bad things may happen if you will omit this or that cast.
Yeah.
It looks okay when I'm saying this. It looks like okay. Probably it makes sense, but I would be really afraid of changing anything because I believe every call, every cast matters here. So it is really hard to maintain also.
Yeah, I can imagine a friend running ARM, .NET on ARM, and then just me being called in the middle of the night with the call that it doesn't work on my machine. And the answer would be it works on mine because it's x64 CPU. Yeah. So again, going back to the hardware abstraction problems. Yeah, so that was before native integers were introduced, and I think that you perceive it as a bit complex. So now I highlighted these two lines. The first, you can see that we use nint, native integer, for arithmetics. It basically does the same, so it will avoid these unnecessary truncations and will ensure that on a machine that has 8 bytes long word, it will be 8 bytes long. For machines that has 4 bytes long word, it will be 4 bytes. And please take a look at the for loop. So it is much simpler now. As you can see, we just assign length to the len, and there is a lot of code that was removed for this example. I need to add that. But we just assign length to len, and then inside of this for loop, we basically just check whether the index is lower than len. And this is really straightforward, and I see it as like a regular for loop, even though it deals with all these native sized integers that ensure, again, that we deal with properly sized integers aligned with the number of bytes provided for the machine word on this specific hardware.
So it looks much better now. And it is even strange that it hasn't been like that before.
Yeah. It looks too good after the change.
Exactly. So I hope it cleared a little bit of why are the rationale behind those two types. We can return to this question. And by the way, we didn't mention that previously, but if you have any questions, do not hesitate to interrupt us, because we really love questions, because it is kind of interaction that you are not sleeping, for example. So if you have any questions, do not hesitate to interrupt us with them. Even if they are something like Chris asked, sorry, not Chris, but Kevin asked, I hope you are hearing me a little bit better now. I've increased the volume of my mic to maximum, so I hope it will be better. So returning to the question, so what's the difference between IntPtr and int then?
Yes, so if we compile a code that uses native sized integers, we will see that the actual metadata for this specific variable or a field, basically whatever, will use IntPtr, IntPtr type. But Roslyn adds an additional attribute, and this is like a really truncated version of it, because it has like a really huge attribute on top of that. And you can see that it has, and it provides an array of transform flags. And so the structure is as follows. Nint or uint, it will use and will be compiled to IntPtr or uIntPtr. But additionally, on top of that, there will be added an attribute in metadata, the mentioned native integer attribute. And I think that I could try to describe it in depth, but let's take a look at an example that will try to that will show it in a better way. So first, the very first line, if we have, for instance, a variable called a, and we compile this code, we will see that the output, the a will have the IntPtr type, but it will have no native integer attribute. For the second case, b, that is nint, it will be again compiled to system IntPtr, but it will have added native integer. The same goes for I enumerable of and uint. Again, it will be provided with the native integer. And the last but not least, that's a really interesting case, because we can have a tuple of two values. That first, that's the IntPtr, the second is nint. And as you can see, then again, the output value, it will be value tuple with two IntPtrs, but it will have this native integer attribute added with the first flag set to false, because the original type was actually IntPtr, and the second will be set to true, where the original type or the original alias of the type was nint. So as you can see, the output metadata, by the metadata I mean the actual type of this specific variable, will be always IntPtr, but whenever you use the native size integer, it will have this native integer attribute added. And again, beside the native integer attribute, I think that the biggest difference in this case between the IntPtr and int, I think it's readability and much less cognitive overhead that you need to, and like the complex mental model behind IntPtr that you need to load to your head whenever dealing with span helpers or any other kind of low-level code.
Awesome. So we can say that those two types are kind of wrappers around IntPtr type, which adds some additional behavior, and this attribute that is then interpreted by JIT or another magic.
Speaking of JIT,
or it is not seen by JIT at all, and it is.
I'm not sure if it's seen. For sure, native size integers allow you to properly check for, like, instance, like the span length, and then it is JITted properly. But I don't remember whether or not it's based on the attribute itself, or is it based on the actual underlying type of this specific variable. So I would need to check that. But anyway, using the native size integers will allow to both kick in the proper JIT optimizations and at the same time lower the overhead for dealing with such low-level constructs.
Great. So we have something for our .NET spicy way of seeing things.
Sprinkle it a little bit with the spiciness.
And function pointers on the other hand, but it's only 1 hour webinar, so we can move on. And we covered nints and nuins. It's pretty hard to pronounce, but it sounds really awesome for at least some scenarios. And from the other hand, I've chosen a little different set of features which are related and probably mostly created for the purpose of code generators, which is another, on contrary, high-level set of features that has been added to the whole .NET ecosystem. So skipping and jumping from the lowest of the low parts of the C# language, let's move to the high part, which will be about those features which are related to code generators. So why this is, why I perceive it as an important thing, all this stuff related to code generators and those features that has been added. First of all, maybe some explanation about partial methods, because it sounds pretty magical if you don't met this concept yet in C#. First of all, we have a partial class, right? All of us is using partial, maybe not all, but most of us were using partial classes more or less in a conscious way, because, for example, and mostly they were added because of IDE editors. So, for example, if you have Windows Forms application and you have a Windows Form editor, partial class is pretty important concept that is supporting you being able to write code for the handlers of buttons or so let's just recall this concept in a few clicks. Imagine that you have a Windows Form application. We are writing Facebook 2.0 because it sounds like a good idea. And we have 2 buttons, and if we are making a handler that will do something when it is clicked, obviously we are adding a handler for it. Let's say that application exit will be called, because we do not like dislikes. And as we see, this is a partial class. That was the thing added because of that, because we need to split our class into 2 parts. The one that is auto-generated because of the whole thing describing this form, and another part which is the code that we would like to add. And we cannot have it in a single file, because then it will be constantly overwritten by the generator. So we have the part that is written by us by hand, and then there is this second part, which is another part of this class, but in the second file, which is auto-generated, right? So the concept of partial classes is pretty easy to grasp. We have multiple files with the same class definition, and in the end all those parts are merged to a single class definition. And that was mostly because of designers, we can say. But then we have also partial methods, and this seems pretty scary at the first place. Like, could we split a method definition implementation into several parts? It would be nice to see such a feature, but it is not the case for what those were designed. So we cannot make something like occur partial void, do something and then make a second part of it, because we would have and split it into several files, for example. That sounds like a nice idea, but would we have a pretty big problem with the order of it, like in what order we should merge all those methods, right? So we cannot do that. It is not the case for methods that the partial keyword has been added. If the language was forcing a particular order of files, maybe, but C# is not forcing an order of files in the solution, so we cannot rely on this, and we cannot use partial methods for splitting method implementation into several parts. So why partial methods were introduced? Because they prior to C#9 they were introduced to make kind of optional methods implementations. So you can have a partial void method like here, and as we see, we don't have a single definition of it, and still this solution will compile, because it is only saying that, okay, this is a method, but I don't care, it may not have implementation. And if no one is calling it, we will be just leaving it with the fact that no one is, if it is not called, it is not required to have an implementation, so it will compile. Unless, obviously, we will add usage of this partial method, then the compiler will have an error that I'm using a partial method that is not defined, implemented anywhere. So we should treat a partial methods before C#9 just for that, an optional method that can be not implemented. That's why I added it for logging, for example. I can imagine I'm just implementing optional logging that way. But obviously it would be a problem if, for example, this optional method would return something, because then I can have code that would be relying on the result, and then maybe this code will be interested in this result or not. So there are pretty strong restrictions what a method, what kind of method can be partial before C#9. And there were those restrictions that, first of all, this method should be private. So we would not like to expose this optional compilation outside the type, because it would explode, not because half of a program could be an optional now, because it will depend on the fact that whether this particular method is implemented or not. It should be void, and it should not have out parameters. So anything that would be kind of, we cannot consume the result of the method that can be not implemented. And there was the partial methods before C#9, which I agree is super rare. I don't remember I was myself writing partial method. I don't know, Szymon, if you were using partial methods, but
I saw a project where it was again related to be founded on the code generation things and providing kind of a framework for structurizing the code of other teams. So the partial methods were used in there for basically provide you the way to inject yourself in different parts of the life cycle. But me myself, I haven't used it.
Yes, I haven't used it also. So they were pretty not so popular, let's say. And now C#9 added and returned to this idea, but has removed all those restrictions. So now, since C#9, we have partial methods that can be public, then can return a result, and they are just any method in the end can be partial. But there is another result of these restrictions being lowered, that the implementation must be provided. So since C#9, we can write a method, partial method, that will return something. It is public, but on the other hand, if we write partial method in one part of our application, we need it to have it implemented in another part of our application. Which seems to be pretty strange, why we should split something. Like if we have an implementation here, why I'm defining only a partial method there, which can be seen as a kind of declaration that I have such a method and then I have an implementation. And first of all, because of the backward compatibility, there now we have two, let's say, flavors and behaviors of those partial methods. If there is no access modifier specified, so like in the case I was showing you previously, if there is no public here or private, it is in C#9 behaving as previous. But if I will add here private, public, protected, anything, then it will switch to this new behavior, which means now I will be able to recompile it to the C#9, and it will and now the compiler will force me that I need to have this implementation somewhere. Because it has switched to a new behavior, even if it is private modifier, which means it is the same modifier like the one that was assumed, but still it is changing the behavior now. And why this is all beneficial, and this is even the rationale provided by Microsoft itself. It is a pretty nice fit for code generation scenarios that I will show you, which drives us and leads us to the topic of code generation in general, which is pretty related to the .NET 5, C#9, and so on, which I believe is super powerful thing coming to .NET. Maybe a little bit underestimated now, but it will for sure change a little in the ecosystem, the source generator concept. So what are those source generations, code generators, source generations? Maybe it is a better name. Officially it is not called source generator. So source generator is a super powerful feature in the compiler and the, let's say, compiler and compiling ecosystem, that you can plug your own piece into the compiler pipeline that will generate some code based on the code that it is being compiled. So you have your regular application, your types, your methods, fields, and you can write a plugin that will add something more based on this code. So having source generator, the pipeline looks like that. You have the compiler running. If you are writing source generator, you can write a part that will analyze the source code that is incoming to your app, to this code, to this source generator, and generate a new source based on that. Which, okay, maybe it doesn't sound so sophisticated when I'm describing it, but in general it allows to make super powerful modifications and let's say it, improve a way how we are coding, making a lot of things being automatically generated, for example. That's the first thing. Moreover, it allows to get rid of reflection in many places, because reflection is pretty often used when we need to auto-generate something based on some data, but we need to make it during the runtime because we didn't have a convenient enough place to do that since C#9. A typical example, you have a JSON file, you have a kind of expected structure of your JSON data that should be deserialized or serialized, and current serializers will analyze it on runtime, and with the help of reflection will emit serializer, deserializer that is responsible for doing the work related to that, which obviously means it will be a little bit slow because it uses reflection. On the other hand, it will be a kind of blocker for every scenario that is taken now by Microsoft, which is ahead of time compilation. So they are trying to allow to use .NET applications be compiled ahead of time to get rid of any things that are related generated at runtime. So every time we get rid of reflection, we are getting closer to this ahead of time approach, let's say. Yeah, so that's very nice and pretty important thing from this perspective. But moreover, it just allows to make very convenient helper tools for us for an everyday living. And having all said that, I would like to show you some demos related to that. So imagine that you have, let me just switch to the Visual Studio. Source generators. First of all this source generator stuff is in preview, so they can say that in a strong way. They didn't manage to add it to the .NET 5 at the time of the .NET 5 announcement, but it for sure be in months, in weeks, I don't know, made out of the preview. Currently it is in the preview, so if you would like to play with source generators, you need to be aware that it is not super stable. It is in preview. It may not work as super nice as you can expect, but it is really, really advanced already. So I'm using here Visual Studio Preview because they added also some features related to source generators into the latest preview of Visual Studio 769. And the whole concept is that you can auto-generate the code, as we said. So first of all, a lot of developers will benefit for sure, because there will be a lot of source generators just available for you as a NuGet package. So you will be able to add this or that feature just because you can just add NuGet package to your application and use this feature. I will show you some examples. But most interesting part for me, for example, is that authoring source generators, that obviously now we can start to think what you could write as your own source generator. And this authoring part, creation of source generators, also is being supported already in preview. So I implemented, for example, a source generator with a super not useful feature that will allow you to add a method for every field, and this method will print the value of this field. This is just an example of auto generations, and the whole power of Roslyn, which is the C# compiler, is at your hands. So you can plug into the C# compiler and do everything you would like to do with the source code, including adding methods, for example. And first of all, because of that, we will probably get used to the partial classes, because one of the main characteristics of source generators is that they cannot modify existing code. So if we have this class, it will for sure be like that. We cannot change with source generators that, for example, it is not public but private. It is the code that it is immutable, let's say. With the help of source generators, we can add more things, and because we would like to add more things, we need to have a place for that, which means if we would like to augment user class with some more code, this class needs to be partial, which is nice, another usage of partial classes since Windows Forms and other stuff. So this is a partial class, and my magic source generator is adding this kind of method for every field that is augmented with the printable attribute that is also this printable attribute is also source generated. So it is not in a file that I've added, it is also generated by the source generator itself. So here I have this print field method. If I would like to see another one, I don't have any other methods related to that. And if I'm adding another, let's say other field, I've added this field, but still I didn't add this attribute, so it is not visible as another method. But as long as I will add a new, and as soon as I click save, because source generators are all the time working in the background, so they are recompiling this source and trying to look around whether they have something to add, and they have, because I've added this attribute. So now you will see that I have print other field auto-generated in the background. I even don't need to recompile the whole solution because of the Roslyn niceness and its incremental way of working. It is all working in background, which is really nice. And now I have print other field method also added. If I reduce this, I will immediately see that I don't have this method anymore because the source generator has removed this method. So this super powerful thing that runs on the fly, adding things to your code. And what's nice is that in this Visual Studio preview, recent preview, you can even look at the source code being generated. If you will look at the, let me just use the zoom it for you to have better view. And the zoom it live zoom control 4, okay. If you add, how you can add generator to your project, it is as simple as just adding just a NuGet package with the source generator. So it is pretty easy, and you will be able to add source generators like that. And if you add source generator to your application, to your project, and since this preview of Visual Studio, you will see analyzers. And I don't see it here because I didn't expand it the correct. So yeah, we see these analyzers. We see that I've added this particular analyzer, and then I see the files that were on the fly modified. At least they should be, because in the preview it is not working so flawlessly. But in general, we see what this generator has added, what has been the code that has been generated. And we can even set breakpoints here to analyze the code that has been added, and so on and so on. So it is pretty nice thing. And we see indeed that those two methods has been added. This is auto-generated from source generator. And this attribute, as I said, also is auto-generated, so it is added by the source generated on the fly to the project. And that's pretty powerful thing. How this source generator looks, just to give you an example. If you have ever authored the source analyzers, a Roslyn analyzer, it is very similar one. You simply need to plug to the C# compiler pipeline, adding some magical things that will start to generate your code. And this is string-based API, unfortunately. So as you will see, for example, if I would like to add this particular attribute, I'm using just a proper string content, and at some point in time I'm saying, okay, I would like to add a source code which will be in this file. This is an identifier interpreted as a file name with this particular text, and this means I've just added this code to my project under this name. And obviously I can auto-generate those strings, so I'm here creating those printable file with the proper name, which has been generated from the code, and this is all based on string concatenation, string builder, and so it is interpreting the plugging it into the Roslyn, getting, for example, all the fields of the type, and so on and so on. This is probably not the time for explaining all this. What is really powerful here is that there are no limitations in the end, almost, what you can do with that. So super nice thing that will change a lot, I believe. So this is the demo about the source generators, and coming back to the partial method. Why we would bother about what we can see that partial methods are a part that were added because of source generators, because now you can augment, you can auto-generate the implementation of those partial methods. So my magical source generator is also able to implement a method with a given specific name. So I've coded there that if my type is having a partial void print all fields, as far as I remember, method, this is auto generated by the compiler. Unfortunately, there is some error, but as we see, it should compile. Even I have no implementation for that in my code, my source generator is detecting a partial method with such a signature and adding implementation for it. And if would be working nice, oh, even it is. So we see that in the end, my source generator added this particular method, which was just some default implementation. But so now, with the help of partial methods, we have this split between the declaration of a method, and source generator may provide you an implementation for it. That's the split, and that's why the partial methods are so powerful. Maybe this print all fields is not so super sophisticated, but one of the examples from Microsoft is, you imagine that you have a public partial bool is email string input, and here you are saying regex generate and some magical regex to detect emails. And with the help of source generators now, at compile time, you will have an opportunity to generate source code for this particular regex check, and the implementation for it will be just provided for this particular method. So omitting reflection at all, the source code for this particular regex can be emitted, which will be for sure optimized, and so on and so on. And you will have an isEmail method as a code that is now fast, generated at compile time, and so on and so on. Or you can go, in fact, any sub-language that is kind of domain-specific language can be implemented like that. You can, I don't know, make a language that will be just for, I don't know, some calculations, and then you will create a source generator that will generate you a C# code that is for calculating this particular equation or so. So we can expect this kind of usage with the help of partial methods. Not having said that the source generators in general are super powerful.
Yeah, for some reason it makes me thinking about all the abusive ways that I can use it. For instance, writing a generator for generators that will generate code, or the other way, maybe like writing generators that are based on names, and then thinking about like the really introducing a lot of conventions where you just write a name and it is used as the source for the method itself.
Absolutely.
Yeah, but on a more serious note, if you want to take a look at what Konrad said about ahead of time compilation and the overall approach of removing the abstractions, sorry, not the abstractions, but the reflection usage. One of the cases that did some work related to that is the library protobufnet, created by Mark Gravel. So what he did, he basically extracted the core that is independent from the reflection, and that's just the core of the library. And then you have two parts. One part that can be based on the reflection and uses the core. So whenever you have this, whenever you want to have this default behavior, and the other part can be based, for instance, on code generators that will generate whatever is needed, but still the common core code will be provided by the core library of this specific component. So there are many, many more ways that you can interact with code generators. And I think that with Konrad, we have full alignment in here that it's really an awesome feature, and we can expect that different approaches, different tools will be built upon it.
Yeah, exactly. Super powerful. I'm I'm a little bit afraid of what have you mentioned, that now the convention can generate things. So you can write a generation, auto generator that will interpret names like print me a field, and it will print you a field which is a name field. It is possible, absolutely, but I hope we will not abuse it too much, obviously, but it is like with the great power, the great responsibility.
Yeah,
so
we will need to have another Roslyn analyzer that will just run on top of that. Okay, sorry.
Exactly.
Yeah.
What's interesting that, first of all, one thing that luckily has been introduced, a restriction that the source generator is not seeing the output of another source generators. So you cannot change source generators. If you are adding source generator to your project, it is always seeing the original code, not the one that, because obviously it would introduce problem with the order and kind of source generator overflow problem that they will start to generate code more and more advanced. So that's good. But it is, as we said, super promising technology in the end. Kevin has asked whether we can make a partial overrides. So we can. So it is like saying there is toString implementation will be provided somewhere else, and now we can write our source generator that will provide the implementation for it, for example. And another question is whether this source sort will be, I will open source this simple project as a reference for writing your own simple source generators, so you can play with it. And what's more is this feature is super nice. The only problem here is that it is so string based. So you know, it is like string concatenation, as we said. So when you have this source generator code, it doesn't look so super sophisticated. You need to append in a proper places to make it compiled. That's why typically people are using here kind of templating engine underneath, like Scriban or Mustache, or however you pronounce it, to make just a kind of templating engine that will generate the resulting file instead of such dummy string concatenation as I'm doing here. Obviously, we don't have any language driven way of defining your source codes. Like if you have ever played with Lisp is so powerful because its syntax is, by the way, its own definition, because it is just abstract syntax tree. So you can write macros in Lisp which will generate macros because everything there is a macro in the end. C# is a little bit different, so we have to rely on this string approach now, at least. So this is super nice, and just a few examples because we are slowly getting out of time. First of all, you can very simply play with the source generators from this site. So we have something like that, and then you can play with it just providing your own source generator and the output and so on and so on. So without even touching Visual Studio, you can play with it. Another thing is that Roslintin has provided some examples of source generators, including the one that is probably the most important. So generating, for example, there is no JSON example here, there will be somewhere else, but for example, generating data based on CSV file, or another things that are generating classes based on data, which is one of the typical use cases. And another very interesting source generator template from the Roslin team member, as far as I remember. So you can use this template to create your own source generators. And another pretty nice example aggregator of various source generator examples, and there turns out there is a lot of already implemented source generators in a more or less, let's say, production ready way, but you can look around to see what is possible simply, and to look around for the source code just to learn how you can implement them. So it is pretty nice list. And I selected just a few of them to show you, like for example, primary constructor, something that is just generating a constructor for you. So if it has a lot of fields in your type, which is just a lot of dependencies, which probably should not happen because of solid and so on, but imagine you have a lot of fields and you need to auto-generate constructor. For that, you can attribute your class, which now should be partial, obviously, with this attribute, and this primary constructor will be auto-generated for you, which is one of the typical examples of adding some code to your original code. Or, for example, there is Strong Inject project, which is about dependency injection at compile time based on this idea. So Strong Inject, you can look around with a pretty nice documentation. So instead of relying on reflection for the dependency injection, we can rely on source generators now. Or, for example, let's look at the stack XML. This is something interesting for you, Szymon, if you haven't seen it before. This is a XML serializer, stack-based zero allocation. So we should definitely look around here. And this is exactly for how the name states. It is a serializer, which is generating the zero allocation XML serializer and the serializer based on the structure of the XML that you would like to serialize the serializer.
I saw some benchmarks in there, but if you compare, if that was like almost zero allocations, that would be so much better than the regular one anyway.
Yeah,
probably. So yeah.
We need to dig into the code. Still, always when you look at the code, typically if there is the code of it is auto-generated on the string builder basics, as far as I remember. So the result is not so obvious if you look at the code itself. But you can always look at the code generated in the Visual Studio. And all this reminds me Project Lombok, if you are not aware of it. Sometimes when I'm giving training for folks that are changing their language from Java to C#, which is not happening so often, but sometimes happens, they are always asking me for the counterpart for the Project Lombok, which was exactly the same in Java world. There is an auto-generation of the code, and they are very used to various attributes. They add behavior to their classes like construction, disposables, and so on and so on. So we haven't have had anything like that previously. Now we have something eventually that will reassemble project Lombok from the Java world. So we can even look around in this project from Java and to see what is possible, because it is pretty mature.
Or what should not be done at all.
Yeah, exactly. Learn from their mistakes. So I'm pretty excited, we can say, about source generators and what they will bring, because I believe they can really become something really powerful. And I believe it is now good time to sum up. Let's just look around the questions, whether you have addressed to everyone. Yes, we have this opinion that pure text for generation code instead of using any kind of object syntax tree model is not so nice. I agree, but probably, maybe we will meet source generators version 2 or 3 or 5 that will expose syntax trees directly, but in the end, I'm pretty happy with the current solution. Like, you can use templating engine and just generate your source code. How does it work with post processors?
By post processor, you mean like the Weaver, like Foddy, or?
Probably yes. Yes, so they plug into the pipeline before emitting IL. So you have a source code, you have your auto-generated source code being added to the assembly, and then this is all if the compilation succeeded, it is IL emitted. So all those IL weavers will be working on top of that.
Mm-hmm.
And the next question. Even into the digging into the question, probably yes, because you can build almost everything with the help of source generators. What we really need to remember is that source generators work on the method definition level and class definition, type definition level. You cannot go inside the method body to change the body of the method. So if you would like to have a source generator, probably for sure you can auto-generate the whole builder for a type. So you can take a type and provide all the with methods for it. So with first name, with last name, with everything name, for every property that can be set, you can auto-generate the method for it. So yes, it can be pretty useful for auto-generating all those builder patterns. I agree. I haven't seen such an example, so it seems like nice thing to try out when learning, for example, source generators. So, okay, so that's all from my side. If you have any more questions, do not hesitate to ask. We will provide these slides as the link to under the video, so you can click all those links instead of typing them. So I really invite you to do that. And Szymon, anything to add?
I think that we should during the next webinar, we should think about the award for the most abusive usage of the specific kind of technology. I think it would go to cookies with the can we use T4 templates to generate the source generators. Yeah, that's the way we think about it as well. Yeah, but anyway, beside all that we prepared today for you, we've started something else, and as you can see, we are like 1.5 an hour almost in this webinar, and we covered just a few things besides silly jokes related to code generators. But what we are doing right now is that we are in progress of making the C# 9 professional .NET online course. After having async expert and the recent .NET diagnostics expert, we thought that it will be a really good thing to provide you this kind of experience and this kind of knowledge in a course online version. So currently this is the course will be provided by me, Konrad, and Łukasz, and currently we have this promotional price. So if you want to join this course, it's not available yet. We are in progress of making it, but you can join it right now, and will be available around I think April. That was the date, April this year, not the next one. So yeah, I think that's all that we provided. If you did like this webinar, please take a look at the site proc#9.com, and there is full agenda for the course. And we hope that you like this webinar and that you enjoyed it.
And we hope you will write awesome source generators in the future.
Yeah. We do not take the responsibility, but if you want to share that you were inspired by these T4 templates or whatever from this webinar, please do mention us.
Exactly. So just not to make things delay too much, thank you for being there. And I hope you, as Szymon said, you have enjoyed our webinar. Just a kindly reminder, on Wednesday there is another webinar with me about .NET GC internals. So if you like internals of .NET in runtime, you can also see me there during the Wednesday evening. So thank you all for being with us. Thank you, Szymon, for co-hosting this webinar. I hope Łukasz is well, at least better than half an hour, 1.5 before. And see you somewhere in the internet. Have a nice evening.
Take care.